here we're going to find given a function, we're going to find the inverse of the function and its domain and range. So the function we're given is f of x equals x over 2x minus 3, or y equals x over 2x minus 3. So what we want to do is, to find the inverse, we want to turn the function inside out. But when I was looking through MyMathLab, what they do first is interchange x and y. We were doing that at the end, but I like doing it at the beginning better, so that's what I'm going to do here. So instead of writing y equals x over 2x minus 3, I'm going to write x equals y over 2y minus 3. So I'm just going to interchange them now so we don't have to worry about it later. Alright, so now what we need to do is solve this for y, get y all by itself. The first thing we're going to do is get rid of this denominator. We're going to multiply both sides of this by the quantity 2y minus 3, and then it'll cancel on the right side and we'll multiply by x on the left side. So when we multiply by 2y minus 3 on the left side, we're going to have x times 2y minus 3, and on the right side all we're going to have left is y, because it's going to cancel. The next thing we want to do is multiply x, or distribute x across the parentheses. So when we do that, we're going to have 2xy minus 3x, 2xy minus 3x equals y. Alright, what we're trying to do is to get y by itself on one side. So I'm going to move all the terms that have a y in them all on the same side by themselves, and then I'm going to try to factor the y out of them, and then I'll have y by itself. So I'm going to move 2xy over to the right side. So I'm subtracting 2xy from both sides. What I'll have left after I do that is negative 3x on this side and y minus 2xy on this side. Alright, the next thing I'm going to do is, we have a lot of negatives here. We have two terms that are negative and only one that's positive. So to simplify things, I'm going to multiply the whole equation by negative 1. And if I keep going like this, I'm going to end up with y on this side. And I prefer to have it on this side. So just all in one step, I'm going to multiply both sides by negative 1 and flip the sides. So you can pause the video and check to make sure that you agree with everything I did, but I'm going to do that now. So we'll end up with 2xy minus y equals 3x, after we flip both sides and multiply by negative 1. The next thing I want to do is factor the y out of these two terms, because when I do that, I'm going to have y all by itself here, and that's my goal. So when I factor y out, I'm going to have y times 2x minus 1 equals 3x. And now I'm very close. The last thing I need to do is divide both sides of this equation by 2x minus 1, the quantity 2x minus 1, and it will cancel on this side and we'll just have it over here. So after I divide both sides by 2x minus 1, I'm going to have y equals 3x over 2x minus 1. So that is our inverse function. This is f inverse of x equals y equals 3x over 2x minus 1. The question did ask us to find its domain and range. The calculator can be helpful in this, but we did learn everything we need to know in the last chapter. So our domain is going to be every x value that you can input in this function that makes sense. And by that I mean we can't be taking the square root of a negative number, because then we will have a complex valued function and we're only interested in real valued functions. So make sure we're not taking the square root of a negative. There are no square roots here, so we don't need to worry about that. We also need to make sure we're not dividing by 0. So we would be dividing by 0 here if 2x minus 1 were equal to 0. Because right here we have 3x divided by 2x minus 1. So we have to make sure 2x minus 1 is not equal to 0. So 2x minus 1 is not equal to 0. And I'm just going to solve that for x. So we add 1 to both sides, we're going to have 2x is not equal to 1. Divide both sides by 2, and we know x is not equal to 1/2. So if you got out your calculator and graphed it, you would see that as x approaches 1/2 from the left, it's going to dive down towards y equals negative infinity. So dive down the y-axis. If I sketched it, this is our y-axis, this is our x-axis. We know we have a horizontal asymptote at 3/2, right? Because that's the power function of the top and the power function of the bottom. Since they're the same degree, we just look at the coefficients. 3/2, so I'm going to write that here, this will be y equals 3/2. That's our horizontal asymptote. And our vertical asymptote is going to be x equals 1/2. So, I don't know if I'm drawing these to scale, but this is supposed to be x equals 1/2. X equals 1/2. And if you graphed this, you would see that from the left, our function would, start off very close to the asymptote, and then it's going to dive down here and head down towards y equals -infinity. So it's never going to get to the line x equals 1/2. And then from the right, it's going to come from way up here, and again, it's going to approach the asymptote y equals 3/2. So our domain is going to be all x except for x equals 1/2. So for domain, I'm going to put d equals set containing x such that x is not equal to 1/2. That's our horizontal asymptote. For our range, I'm going to say the set containing all y such that y does not equal 3/2, because that's the only y value that we never use. The graph never crosses this line y equals 3/2. It's a horizontal asymptote, so that y value is never used in any ordered pair on the graph. So y such that y is not equal to 3/2 would be the range. And you could use the graphing calculator to help verify this if you weren't quite sure about what you were doing.